Let's consider phase changes. There are three we want to consider. We have solid phase going to liquid phase. We call this melting, but in science terms it is called fusion. And we have liquid going to gas phase. This is called vaporization. And we have solid going directly to the gas phase, and that is called sublimation. Now we want to determine the heat required for phase changes. So we want to know what dq is for a phase change. So D, remember, is just a change. Q is heat. So let's start with the definition of enthalpy, which you learned in the first semester. Enthalpy is equal to internal energy plus a product pressure times volume. So we'll take the change in the enthalpy and we use the product rule for the change of P times V. Then we're going to use the first law of thermodynamics and write du as dq, the heat flow, plus the work performed now we're going to say that we'll only allow pressure volume work, so dW is minus PdV. Now the PdV terms, these two terms cancel, and so we get dH is equal to dQ plus volume times the change in pressure. Well, at constant pressure, the change in pressure is equal to 0. Therefore, dH is equal to dQ at constant pressure. Now, if we integrate both sides of this equation, we'll get Q at constant pressure is equal to just the change in the enthalpy for that process. So this is the equation that we want to remember. So that means the heat for a phase change at constant pressure is just equal to the enthalpy of the phase change. So what if we were considering vaporization? We would have the heat required for vaporization is just equal to the enthalpy change for vaporization, and we use standard state, 1 atmosphere pressure, so I'll use a superscript 0. So we have enthalpy of vaporization. We also have the enthalpy of fusion, which we designate FUS, and we have the enthalpy for sublimation. So now let's look at an example. We have from the table the enthalpy of vaporization for water. And we can find two values. We can find a value of 40.7 kilojoules per mole of water, and this is at the boiling point. We can also find a value in a table of 44.0 kilojoules per mole, and this is at 25 degrees centigrade. So we can see two separate values in the table depending on which temperature we are going to consider the vaporization of water. So be sure you get the right value from the table depending on the temperature at which you're performing the vaporization.